A tangent to a circle is a line which just touches the circle. So the tangent would be that blue line. Now, if I were to draw a line from the center to the point where it touches, this will be the radius of my circle, right? And this is my tangent. The tangent is going to be at right angles to the radius line. That's something to keep in mind. So that's a tangent. A chord. Let's say if I had a circle, I had my center there, and I have a perpendicular bisector. No, I just have a line going straight through. I have a line going straight through my center. The perpendicular bisector. Okay. Now, let's say I have another circle and I have a perpendicular bisector. Okay? And I have a chord. A chord is a line going from one point to another, but it's not the diameter. This dotted line would be the diameter if it goes through the center. It's not going through the center in this case. It's just any random point or from one point to another. In this case, the perpendicular bisector will go through the center. It's going to go through the chord, and this will be right angles as well. So this is my chord, and this is the perpendicular bisector. So the diagram probably makes the most sense. But yeah, that's tangent and that's chord. Let's have a look at some examples and questions which make use of chords and tangents. First question says, the circle has the equation x minus 2 squared plus y minus 6 squared equals 100. Verify that the point 10, 0 lies on C. You want to substitute x equals 10 and y equals 0 into your equation. If your equation equals 100, then yes, it lies on C. So try it. Plug x equals 10 and y equals 0 into the left-hand side, so into all of this. What do you get? Should get 100. 10 minus 2 all squared is 8 squared plus and then minus 6 squared. So 64 plus 36, 100. That equals the right-hand side. There you go. Okay, part B. Find an equation of the tangent to C at the point 10, 0, giving your answer in the form ax plus by plus c equals 0. Okay, what's the center of the circle going to be? 2, 6. And you've got the point 10, 0. So you've got technically 2 coordinates. Work out the gradient of the line connecting your center and the point P. You're going to do y2 minus y1 over x2 minus x1. So 6 minus 0 over 10 minus 2, which is 10 minus 2? Nope. 2 minus 10, sorry. So that gives you minus 6 over 8, which is minus 3 over 4. That is the gradient of the line going from center to P. So if I were to draw it, something like that. The tangent touches at that point, yeah? So tangent at the point 10, 0, like that. This is my tangent. At the point 10, 0, let's pretend that's 10, 0. What's going to be the gradient of my tangent? The minus reciprocal. Because remember, it's right angles. So 4 over 3. And it goes through the point 10, 0. So y minus y1 equals mx minus x1. Y minus 0 equals 4 over 3 x minus 10. So y equals 4 over 3 x minus 40 over 3. If we times everything by 3, then we get rid of the fractions on the right. We want it in ax plus by plus c form. So we get 4x minus 3y minus 40 equals 0. Just move the 3y to the right hand side. Okay, that's that one done. Let's have a look at this question. The points P and Q lie on a circle with center C, as shown in the diagram. The point P has coordinates minus 7, minus 1, and the point Q has coordinates 3, minus 5. M is the midpoint. The line L passes through the point M and C. Find an equation for L. Okay, L goes through the center. That's your perpendicular bisector. So that makes this line your chord. Yeah? So to work out equation L, I want you to first work out the midpoint of PQ. What do you get? You should get minus 7 plus 3 over 2, minus 1 plus minus 5 over 2, which gives you minus 2 minus 3. Okay. Then you want to work out the gradient of PQ. Can you try that? Should have done minus 5 minus minus 1 over 3 minus minus 7, which gives you minus 2 over 5. Okay, the gradient of the line is perpendicular to PQ. So the gradient of L is going to be the minus reciprocal of PQ, 5 over 2. Okay, so y minus y1 equals mx minus x1, where you're going to make use of these coordinates. Y plus 3 is equal to 5 over 2 x plus 2. When you simplify that, you get y equals 5 over 2x plus 2. Okay. Next. Says, given that the y-coordinate of C is minus 8, show that the x-coordinate of C is minus 4. Okay. You've got the equation. It says y equals minus 8. Plug that into this. What do you get? You should get x equals minus 4. Because minus 8 equals 5 over 2 x plus 2. You move that over. Minus 10 equals 5 over 2x. So x equals minus 10 divided by 5 over 2, which is minus 20 over 5 minus 4. Okay, last bit. It says, find an equation of the circle. Okay, we just worked out the center. Minus 4 minus 8. So what we have left to find is the radius. You've got the center. The radius can be this, or it could be that. Either of the two. Doesn't matter which one you choose. But you want to work out the length of either CQ or CP. Both will give you the same answer because the radius is going to be the same. So can you try that? I'm going to go with CQ. So square root of change in x, which is going to be 3 minus 4 all squared, plus change in y, minus 5 minus 8 all squared. When you simplify that, you get root 58. And remember, that is just r. But in our equation, we want r squared. So the center is minus 4 minus 8. So that means x plus 4 squared plus y plus 8 squared equals root 58 squared. Root 58 squared is just 58. There you go. That's the equation of the circle. And that's how you do tangents and chords.